Hello and welcome to another video. In this problem we're going to be working on decoded string at index. And you're given an encoded string S, and to decode it, the encoded string is read one character at a time and the following steps are taken. If the character read is a letter, the letter is written on the tape, and if the character read is a digit, the current digit tape is repeatedly written d minus 1 more times in total. Given an integer k, return the kth letter in the decoded string. So let's kind of go through how this works for this decoding and encoding. So for leet, essentially what would happen is we'd have leet, and then because there's a 2, they're saying take this leet and basically write it again, right? So 2 means like you want to have this 2 times. And then after that, you want to write, let's write over here maybe. There you go. Then we want to write code. And then this whole thing needs to have 3 copies of it. So then we would take this and we would copy it and have 3 copies of it. And so this would be our final word. And then from here, we want the 10th character. So we have 4 is leet, and then 8, and then the 10th character is this O. Okay, so that's the first example. And in the second example, we have HA. And then we want to copy it. So we want to have 2 copies of it. And then we want to have 2 copies of this whole thing. So we take this and we essentially take it and we copy it again. And this is our word now. And we want the 5th character. And so the 5th character is this H right over here. And this last thing is an A copied a bazillion times. And you want the first character, so it's going to be an A. So the reason we can't just like make this string is because I think the constraints here are if you actually write out the string, it's like 2 to the 60th, which obviously is too big. So you can't just like manually write out the string. Otherwise, that would be like an easy problem, right? You take your string, you just code it, you just like copy it a bunch. You can just store your string as like an array of characters or something. So we have to figure out a way to do that without actually copying it. And there is a way to do that. So the thing to recognize in here is, for example, let's go back to this example here. Let's say our k is 10. Actually, in this example, let's say our k is not 10. Let's say our k is, so this LeetCode is 12 characters. So let's say our k is 14. Okay. So we are going to go work backwards to change like the string that we have into a shorter version until we have a k that matches. And so the way to do that is pretty straightforward. Well, it's not super straightforward, but let's just kind of go through it. So essentially what we need to do is we need to go through the string. First of all, there's going to be 2 steps, but let's recognize one thing first of all. So if in this string, this is 36 characters, like this is going to be the key to this problem. If there are 36 characters, if we split it up into the small string, right? So if we split it up into just this, like we say, okay, let's take this LeetCode and let's just actually break it down into just the first copy, right? Let's take it, let's divide by 3, let's take this first part. Well, this k actually can be like, this index can be figured out by just doing k mod the length of the string that you broke it down into. So if we take a look, every string is 12 characters, right? So this LeetCode is 12 characters. So when we do that, we would get 14 mod 12, which would give you 2, right? And so that would give you this character over here. It would give you this E. And in the original string, in this whole original string here, this k is also this E, right? Like this is 12, 13, 14. So essentially, whenever you break down a string into smaller strings, what you can do is you can mod k by the size of that smaller string, and that will give you the new index of like where the letter needs to be, essentially, assuming it's one index, right? And if k was like bigger, then it wouldn't matter, right? So if k was like something bigger, then when you break it down, it would still be fine, essentially. So that's the crux of this problem, is you need to recognize that when you make a word go into a smaller word, you can mod your k by that smaller word to get like where the new index is. And that's going to be the crux of the problem. So what we are going to do is we're actually going to walk through this like step by step and then kind of show you how we get a solution and how it works. So the first thing we need to do is we need to calculate the length of the string. And while we can't really get the whole string, we can get the length. And so the length is going to be pretty straightforward, right? So let's say we have this string, and let's actually write down all these characters. So let's say we have L, E, E, T, 2, C, O, D, E, 3. So to get the length, we can simply have a length variable, right? Let's call that L. And then we can just go character by character. And if it's a character, we can add 1 to the length because you're simply appending a character. And if it's a number, we just multiply whatever string we have by that character. So let's kind of see how that'll work. So we're going to go through this string, right? And we're going to put it in L. So that will give us 1. Then we're going to put in E. Then we'll get another 1. Then we're going to put in E. We'll get another 1. Then we're going to get T, get another 1. Now we go to a 2, so we multiply by 2. And obviously we're going to do this like as we do it. We're not going to write it like this. We're actually going to be calculating, but this is just kind of how to show you. So we're going to multiply this whole thing by 2. Now we're going to add 1. Then we're going to add 1. Then we're going to add 1 and add 1. And then finally we want to take this whole thing and multiply by 3. And so let's see what that happens. So this inner part is 4 times 2, which is 8. Then you're going to want to add 4, so plus 4 times 3, right? So it gives you 36 characters. So that's how you get the length. It's pretty straightforward. Like you just literally take whatever your old length was, and if it's a character, you add 1. If it's a number, multiply by that number. So now we have a length. And now we need to actually walk through this backwards to kind of do this logic backwards and doing this mod thing and figuring out where our k value is going to be. So let's walk through that. So here we have this string, and let's actually write down, let's also copy this as well. There we go. Okay. So essentially our k is 10 in this case, right? That was our original problem. So essentially we're going to be walking through this character backwards and updating the size. So our size, and I'm just showing this LeetCode kind of just to represent the string. So we're not actually going to have access to this string. It's just going to represent what it looks like to make it easier. So our length is 36. And essentially we need to walk backwards now until we can get a character that we know where it is. And we're going to kind of see how that works. So for every letter, what you need to do is you need to check, is it alphanumeric or is it a number? And if it's a number, so if the letter is a number, which it is, then you're going to want to divide your, well, actually the first thing you're going to want to do, and I'll show you why this is you're actually going to want to k mod equal your length of the string. So in this case, it would be 36. So that would just be like, what is, so it'd be, yeah, it'd be k mod 36. So 10 mod 36 is just 10, right? So here our k would stay the same, it would be 10. Now, we get a number. And so if it's a number, then we take our old size and we know it's going to be divided by 3, right? Because we're working backwards. So it's going to be 36 divided by 3, right? Which is going to be 12. And that makes sense because essentially we have this thing. Now we are getting rid of this 3, which means we only have one more copy of LeetCode. So then our length becomes 12. Our k stays the same. Our k is 10. Let's actually get some more space here. So let's have, yes, our k is 10, our length is 12. We'll just keep updating here. And now this is our string. Now we are on this character here. We are on this one right here. And so the first thing we're going to want to do is, like I said, we're going to want to mod it by the length. So 10 mod 12 is still going to be 10. So that doesn't do anything, right? And that makes sense because this is still in the original string, so this shouldn't be modded, right? That's what I was saying. Like, if the string is smaller than k, then k will change. But if the string is still bigger than k, then k will stay the same. So now we take this e, and essentially what we need to do is we need to say, okay, so this is a character. We can try to figure out what k is. So k K is still in our word, right? And we don't have access to any character except for the character we're currently on, right? We don't have access to this actual string. Let's make this bigger, actually. We don't have access to this string. All we have access to is the current character we're on. So because K is 10 and we're at a character, that means we need to actually do something here, right? So we need to change our size. So because we're on this letter, we need to actually get rid of this letter from our size. So essentially this is like crossing off this letter here. And that means our size is going to get reduced by 1. So anytime we're at a letter, we're going to reduce the size by 1. And so that's going to be 11 now. And then again, we do K mod size. So 10 mod size is still 10. Now we're on this letter. And we are essentially getting rid of this letter now. So we update this length to be 10 now. So now it's 10. So now, when we're on this letter, we're going to do K mod L again, right? So K mod L. But now it's 10 mod 10, which is 0. And so if we get a 0 and we're on a letter, that means we're on the letter that we actually care about. And that makes sense, right? Because we are on this letter, like in our word, and this is the letter that we need, so we can actually just return straight away. So we can return 0. But if you are going to have a case where the index matches, like K will be 0, but if you get a number, then you can't return, right? Because then the problem is the index does match, but essentially what happens here is this is not a letter, this is a number, so you can't just return that. So then you have to keep going. So pretty much your return condition is when K equals 0 and we have a letter. Because that essentially means the current letter we are on is the letter we are trying to return. So essentially, once again, to walk through it, you go backwards through your word. Anytime you get a number, you divide your size by that number. And then at the start of every iteration, you mod K by L, and you check is K 0. And if K is 0, that means the size of the word is exactly what K is, right? For example, like here, K is 10. K is 10. Which means you want the 10th letter, and the size of your string is 10 as well. So if we want the 10th letter, and we have, you know, our current string is length 10, and we're on the last letter, right? Because we're iterating backwards, so we're always on the last letter of the word we're on. So if this is length 10, and we're on the last letter, and we want the letter at 10, then we can just return straight away. And so that's pretty much how you do it. It's a little tricky, but yeah, essentially you get the total size, and you just work backwards until you get the letter you want, until K is 0 and you have a letter. And the reason you have to do this, and you have to do this every single time, is because for that like A, 1, 2, 3, 4, all that stuff, if you only mod K every time you hit a number, not just every letter, then the problem is K will be 1 here, and you're never going to get a solution. Because when K is 1 and the length of your word is 1, it wouldn't work. Like, you can try to walk through that, essentially. So the best way to do it is to mod right at the start of the loop. And so we're going to go through the code, and it's going to be a little bit more like easier to explain there as well. It's definitely kind of a confusing problem, and it doesn't really use a particular algorithm, so it's definitely kind of confusing. But yeah, essentially, you get the length of your word, and you just work backwards until you get a letter. And the whole key to this problem is recognizing this part here, where if K is like 14, and the length of your word goes from 36 to, you know, something smaller, 12, then the new K is 2. And that would be the same index as this one over here, right? Because essentially you're just modding it by the length of your word. So if it's 14, you can imagine it's going to be like 12 letters, and then a new instance of the word, and you're going to be on the second letter in the word, kind of like how it is here. Okay, so let's code it up now. So essentially we're going to have some kind of like word length thing, and we'll make that 0. Then we have to go through every single character. And so if the character is, so you're going to want to use is alpha for these things. Is alpha just checks, is it alphabetic? You can also use ord. But yeah, essentially you want to check for, or you can check for like is num or something. So if it's an alphabetic character, then we can just add 1 to the word length because we're just adding 1 letter. Otherwise, it's a number, so in that case, we have to actually multiply it by that number, right? We're taking our current word and multiplying it by that number to get our new word length. So word length times equals that number. And then we have to convert it to an int as well, because these are strings. So now we're going to be going through our word backwards, and we're going to say for a character in S in reverse order, we're going to mod k by the word length. And essentially, to get the solution, you just have to try it out with a few words and see like what works and what doesn't, and then you kind of get it. So if the character is alphabetic, and like I said, if k is 0, that means we are on the letter right now that we want to return, so we just return that letter. Otherwise, we have to keep decreasing our word length, just going backwards, right? So when we did it before, we added 1, now we subtract 1. And then you also, if it's not an alphabetic letter, if it's a number, you have to divide by that number to get the new size. So we're just literally doing the backwards logic, and we are guaranteed to get a letter here. So let's try that. Let's actually see what the problem is in this one. Tape. Oh, yeah, there shouldn't be tape. This should be word length. And there we go. Tape again. I think when I wrote it before, I used tape. Okay, there we go. And so this is pretty much as efficient as you get for this problem. I think I had it like all over the place, like it jumps around. So let's kind of talk about the time and space for this one. So essentially, we're going character by character here. So this part is going to be O of the number of characters. Now, you can argue also here, your characters are going to get really big. So you might argue that like these multiplications are O1, which would be like a fair argument. Because as your characters get really big, it takes longer and longer to multiply. So you can argue that that's like not O of 1 as your characters get big enough. I think that's pretty reasonable. But I'm just going to say that's O of 1. So this is going to be length of the string. And as we go through it backwards, what are we doing, right? So this is O of 1. This is alpha is O of 1. It just gets like the word of it. And then the rest of it's O of 1. So pretty much this whole thing, every single iteration of the loop is O of 1. We're going character by character, so that's also going to be O of S or O of N or whatever you want to call it. O of N. And for the space, let's see what variables we made here. So we made this word length variable. And we have a k variable. We didn't make a new one. So, and we are converting a character to an int, but that's just one int. So that doesn't really matter. So that's going to be O1 space. And yeah, I think that's going to be it for this problem. Definitely a tricky one, and definitely doesn't really use an algorithm that you have seen before, I guess. So it's definitely not super intuitive. And yeah, it took me a while to get this one, for sure. I had like a bunch of solutions that didn't work. And also I was like, yeah, there's no way they're going to let you just like build a string, because that would be like an easy problem. So not a huge fan of this problem, but here's how you do it if you're wondering. So if you did like this video, then please like the video and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.